Okay, Algebra 2 fans, today we're looking the next day for inverses, and I'm introducing something new, which is called a one-to-one. Okay, so first of all, the definition of one-to-one. Okay, a one-to-one, technically it's a function, a one-to-one function. Okay, so one-to-one function. Okay, so for a one-to-one literally means no repeating x's and no repeating y's. Okay? It's the best way of saying it. So in other words, it's a function. It's a function with no repeating y's. Because as soon as you say it's a function, there's no repeating x's. Okay? All right, so got the definition taken care of. So now let's look at these four choices, these boxes, these four pieces that we have up here. It says, of the four tables below, one represents a relationship where y is a one-to-one function of x. Determine which it is and explain why the others are not. All right, so first of all, let's look at number one. Number one, what's wrong with number one? That's right, 1 is not even a function. You're repeating the 4s and the 9s, so this is not a function. As soon as you say not a function, there's no such thing for one-to-one. Okay? So number 2. Number 2 is a function, right? There's no repeating x's, but look at your y's. You're right, we have y's that are repeating. Repeating y's, so not one-to-one. Repeat y's, not one-to-one. All right, let's look at this one. No repeating x's, no repeating y's. So this is a 1-to-1, let me say that right, 1-to-1 function. Okay, so this is the one-to-one function. Okay, so this was out, that was out. And what do we have here? Right, number 4 is not even a function. Not function. Okay. All right. So now let's look at our next piece. Number 3, we're looking at graphs now. So some of these graphs are functions, some of these graphs are not functions. Okay, so we're going to circle the two graphs above that are functions. They have to be a function. Right, 2 is not a function. Right, that does not pass the vertical line test. Remember, a function has to pass the vertical line test. Not a function, not a function. Okay, fails vertical line test. Both of them. All right. So now, number 1, so these are functions. So this is a function, and this is a function. Okay. Now, one of these is one-to-one. Right. One-to-one means no repeating y's. So if I draw a horizontal line in here, that shows repeating y's. So not 1-to-1 fails horizontal line test. So this is a one-to-one function. One-to-one function. Okay. That passes our horizontal line test. All right, and then down below here you can read about it, a horizontal line test. If any given horizontal line passes through the graph of a function at most one time, then the function is one-to-one. The test works because the horizontal lines represent constant y values. Okay. Alrighty, so that's how we can tell by looking at a picture. Alright, so number 2. Which of the following represents the graph of a one-to-one function? So which one of those is one-to-one? It has to be a function, and it has to pass the horizontal line test. 1 is not a function. It's not a that fails the vertical test. So the only one is choice 3. That's right. All right, which function is not one-to-one? So not one-to-one, what are we looking for? Repeating y's. First of all, it says function. So every single one of these will be a function because they say it's a function. So we're looking for repeating y's. Which one has repeating y's? 1, 2, 3, 4. That one has, all the y's are different. So that one's not it. Looking for repeating y's. No repeating y's here. Looking for repeating y's. 1, 0, 3, and a 2. No repeating y's. So that leaves choice 4. Okay, right there. We have zeros are repeating. Okay. All right, which function is one-to-one? Okay, so if you know what these look like without your graphing calculator, then you're fine. If not, I'll draw little pictures. F of x equals absolute value of x. Yes, that is the V graph. Is the V a one-to-one? No, it fails the vertical line, horizontal line test, so this is out. 2 to the power of x looks like this. 2 to the power of x looks like this. That's this curve right here. That's 2 to the power of x. So this is our one-to-one function. Okay. Y equals f of x, f of x equals x squared. That's your parabola similar to the V. So that is out. And a sine curve is this curve, this graph right here, which we'll graph later on. And as soon as we have these little humps in here, it is not one-to-one. Okay. All right. So from the other day, what did we learn about inverses? We have to switch x and y. Switch x and y. By the way, that's a reflection that you learned in geometry. When we switch the x and the y, that is a reflection over y equals x. So when we reflect over the line y equals x, okay, we have our x comma y becomes y comma x. Okay. All right, so now here we go. And what's our notation for inverses? That's right, it's f with the -1 of x. There. We can write it this way, or we could write it f with the -1 without the x. Both of these means inverses. Okay. Now the whole reason we want to know if a function is one-to-one, because if a function is one-to-one, then its inverse is also a function. Okay. So if a function is one-to-one, then the inverse is a function. Okay? So if we have no repeating y's, when you switch the x and the y's, those y's become x's, no repeating x's. Okay? That's what it boils down to. So this is mucho important, very, very important for us. Okay? If a function is one-to-one, then the inverse is a function. Okay, make sure you can see that. All right, so let's look at my exercise 5 here. If the point -3, 5 lies on the graph of f of x, then which of the following points must lie on its inverse? Remember, inverse, we switch the x and the y. So which one has -3, 5 switched? That's right, 3. Okay. Number 6. Given g of x is equal to f of x minus 3, we're going to evaluate each. So notice it says g inverse. All right, now what does g inverse mean? Well, this is the x of the original function. G is the y of the original function. So g inverse is referring to the y of the original function. So this g inverse is the y of original function. So in other words, where do I put 1? We put 1 in the position of the g of x, in the y spot. So we're going to write 1 equals 4/5 x minus 3. Now I just have a little algebra to do. Okay? G inverse is the y of the original. All right, so I just got to add 3. And then I could multiply by the reciprocal, or else we could cross multiply. So I'm going to I'll multiply by the reciprocal. So 5/4 and 5/4. So what do we have? 15 over 4. So we have 15 over 4 equals x. Okay? So if we were thinking about this as an ordered pair, 15 over 4 is the x value, 1 is the y value. Okay? Same thing, g inverse. The negative 11 is the y of the original equation. So negative 11 is the y of the original equation. Okay? Y of original. All right, so I'm going to add 3. And then I'm going to multiply by my reciprocal. So x equals, that's right, 4 goes into negative 8 twice, so we have negative 10 when it's done. Okay, type that in your calculator if you're not sure. 5 over 4 times negative 8 gives you negative 10. 4 goes into 8 twice, so negative 10. Okay, last one. Where do I put the 4? That's right, it's the y of the original. So 4 equals 4/5 x minus 3. So I'm just going to add 3. And I'm going to multiply by my 5/4. So we have 35 over 4. And we're done. Okay? I'll let you digest that. We got one more page of work to do. A lot of graphs to look at. That's all. All right, last one. Last set. A little bit of algebra down here, a little bit of work up here to do. So the table of values for the simple quadratic function f of x equals x squared is given below. So here's our basic parabola. Graph the inverse. What does inverse mean? That's right, switch all your x's and y's. So every single one of these x's now become y's. So negative 2, negative 1, 0, 1, 2. There, that's not hard. And then up here, all of these y's are your x's. 4, 1, 0, 1, 4. Now I just got to plot my points. So here's my 4, 1, 1, 2, 3, 4, up 1, up negative. So 4, negative 2, 1, 2, 3, 4, 1, 2, over 1, down 1, 0, 0, 1, 1, and 4, 2. There. What do we notice about this? Sideways parabola. It's not a function. What do you notice about the graph of the function? Not inverse in, here, I'll write it out, neater. Inverse is not a function. Okay? Because the original was not 1-to-1. Because original is not 1-to-1. Okay? See? And that's what they wrote out here. The existence of an inverse function. A function will have an inverse that is also a function if and only if it is 1-to-1. Okay? That's what we said. All right, so now we got a little bit more algebra to do here. Okay? So just like the notes from yesterday, so I just wanted to do a couple more challenging questions with you guys, because the algebra is good. You guys need to know how to do this algebra. And it's not hard to do. Okay? The algebra is easy. Don't get scared. It's just algebra. So, first things first, I'm going to save myself some space, make that a y. Then we're going to swap out our x's and y's. Remember we did that yesterday? Swapping out the x's and the y's. So I have x equals y to the third plus 4. Now I just got to make this say y equals. So we'll subtract 4. All right, now how do I get rid of a power of 3? The other day we did squares. We took the square root, so now power of 3, it's called take the cube root, or the third root. And when we do the third root, we don't have to worry about pluses and minuses. That does not exist. So we take the third root of both sides. So we have y equals the third root of x minus 4. Okay? And because I'm using this fancy f of x notation, we need to rewrite this. So it becomes f inverse of x is equal to the cube root of x minus 4. That's just the proper way of writing it out. Okay? Nice and easy. All right, here. G of x. All right, so first things first, make that a y. All right, so I'm going to swap out my x's and y's, just like because that's how we did our inverses. So we have x equals the fourth root of y minus 3 minus 6. And now we just have to get this stuff all by itself. We add 6. And it's the fourth root of. Now, how do we get rid of a fourth root? That's right, we raise to the power of 4. Oops, I just bumped my phone. Hang on, I bumped the camera. Don't freak out. There we go, all set. We raise each side to the power of 4. Do not multiply this out. Just leave it. I told you that the other day. We're not going to square this mess out. We're not going to raise to the power of 4. We're not going to write this out and multiply it out. You just leave it. If you do it on your paper, that's your own darn fault for not listening. And now I just have to add 3 and we're done. All right, and then we got to go back to our fancy notation. This was the letter G, so we're going to write G inverse and now it's officially done. Okay. I'm just going to do this one right here. I'm going to skip D, so we're not going to do D. So this is the last one that we're going to do. All right, to begin with, all right, it says h of x. So we're going to start by swapping this out with a y. And then we have to swap out all our x's and y's. So I have x equals 3y minus 5 over 2y plus 2. Okay, now what do? Don't freak out. This is not hard. It's as easy work. First thing we're going to do is cross multiply. If you have to, put a 1 under here. You don't need to, but if you have to, put a 1. So we're going to cross multiply. So I have 2y, oops, 2xy, I should write it out in alphabetical order. So I have, actually, you know what I want to do is I'm going to put it on another sheet of paper so I have more room. Okay, so we're going to cross multiply. So we have 2xy plus 2x, so I multiplied everything by x here, x times 2y, x times 2, equals 3y minus 5. Okay? Remember, we are solving for y. That means we have to get the y's all on one side. So I have a 2xy here and a 3y here, so I'm going to get all these y's on one side. So I'm going to put this 3y on the left-hand side, and I'm going to take this 2x, I'm going to move it the other way. So this 3y, I'm going to move to the left, so we're going to get all the y's on one side. And I'm going to take this 2x, move it to the right. So I have 2xy. How do I move a positive 3y? That's right, subtract. And how do I move a positive 2x? That's right, subtract. There. Now, I have all the y's on one side. I cannot combine them because these are different terms. The only thing that we can do is to factor out a y. And then, this is a big giant product here. We just divide by this 2x minus 3. And then we're done. So we're going to divide both sides by the 2x minus 3. And then we're officially done. Y equals negative 2x minus 5 over 2x minus 3. Okay? We use the h of x notation. So h inverse of x is equal to negative 2x minus 5 over 2x minus 3. Done. Okay, that was it. That's not that hard to do. It's a little bit of algebra involved, but that's it. Okay, I can do one more. You want me to do one more? I'll do one more. I'll do that last one. So we have the a of x is equal to x over 3x plus 2. All right. Change this to a y. So we have x equals y over 3y plus 2. That's right, we cross multiply now. So it's 3xy plus 2x equals y. Now, what I'm going to do is, because there's no other value over here, I'm going to take this 3xy and just move it the other way. So I'm going to take this, so I have all the y's on that on the right-hand side, so I can leave this 2x alone. So I have 2x is equal to y minus 3xy. And then notice you have the pair of y's. We have to factor it out. So I factored out the y. And now I just divide by this. And we're done. So y equals 2x over 1 minus 3x. That was nice, easy algebra. Yes, I know, technically, we should be writing a inverse of x is equal to 2x over 1 minus 3x. Sorry for the long video, guys. But that's a lot of good algebra there.